An object is a collection of key-value pairs. In this example, employee is an object that has 4 key-value pairs. The keys are on the left side of the colon and the values are on the right side. For example, first name is a key and John is a value. Note that the keys can be specified with or without quotes. A key-value pair is known as a property, and keys can also be referred to as property names. Commas are used to separate the properties, and the entire object is surrounded by braces. It is legal to write all of this on a single line, but it's more readable to use line breaks. An object can be treated as a single value. For example, we can do a console log of employee, and all the key value pairs will be shown in the console. We can obtain individual values from an object by using either dot notation or bracket notation to specify the key. The dots and brackets are known as property accessors when used on objects. Note that department is a string when using bracket notation. This makes bracket notation a bit more verbose, but bracket notation can be used on keys that have spaces and keys that are numbers. Bracket notation also allows the key to be specified in any way that a string can be specified. For example, it can be a variable that holds a string. Note that key name does not have quotes around it because it is the name of a variable. This variable has the value of ID, so this code would be equivalent to accessing employee.id. Bracket notation also allows the use of concatenated or interpolated strings to specify the property name. These techniques for getting a value in an object can also be used to assign values. During the initialization of the object, it is also possible to use brackets to specify property names indirectly. This code uses the category variable to set the property name as department. The ID property name is also created via concatenation. It is not necessary to assign all properties during initialization of an object. It is possible to add new properties to an object using dot notation or bracket notation. You may be thinking that middle name would look better between first name and last name, but objects are not intended to be ordered data structures. They do preserve the creation order of non-numeric properties and sort the numeric ones, but most real-world uses don't involve a simple console log of the whole object. If you want a specific presentation order, you can write your presentation code with the output order that you want. This example outputs first name, middle name, and last name in that order, regardless of the order in which they appear in the object. Any name that would be permitted for a variable can also be used as a property name, but property names can also be numbers or empty strings, and spaces are allowed, although it's generally considered bad practice to use spaces in the name. When using property names that would not be legal variable names, only bracket notation will work. For example, a number cannot be used as a variable name. To use a number as a property name, only bracket notation will work. An important detail to be aware of is that the type of a property name will be coerced to string if it isn't one already. The only exception to that is if the name is a symbol, but we haven't covered the topic of symbols yet. One consequence of this coercion to string is that you cannot have different properties that have the same names that are identical in every way except for their type. The original object definition uses 1 as a string. The second property also has a name of 1, which is specified as a number and not a string. But all property names are coerced to string, so it has the same effect as declaring a second property with the exact same name. This overrides the previous definition, which results in the object actually having only a single property with the second value. Although property names are always stored as strings, property values can be any type, and those types are preserved. It is even possible for the value to be another object. This code creates a nested object. The address property holds another object. If you wanted to access a specific value in the inner object, you can chain property accessors. For example, we can access the zip code by using employee.address.zipcode. This also works with brackets, and it's possible to combine both dot notation and bracket notation. If you have a variable that holds a number, string, boolean, null, or undefined, and you assign that value to another variable, the new variable holds an independent copy. This code demonstrates that changing the value of x has no effect on the value of y because y was given an independent copy of x. Objects work differently, and the new variable holds a reference to the same object instead of a copy. Changing the value of favorite number in obj1 also changes the value of favorite number in obj2 because obj2 and obj1 contain references to the exact same object. This distinction occurs because variables that hold non-object values actually hold those values directly, but variables that hold objects actually hold only a reference to the object. As a result, assigning obj1 to obj2 causes obj2 to get a copy of the reference, so they both refer to the same object. This also affects equality comparison. If you try to test the equality of variables that refer to objects, the object reference is what is tested and not the object's value. The equality comparison in this code evaluates to false despite the fact that both objects are structurally identical. This is because each variable refers to a different object, so their references are not equal. This also means that they are independent, so changing the value of one will not affect the other. If the value of obj1 was assigned to obj2, then the equality comparison would evaluate to true because they refer to the exact same object. A proper general-purpose comparison of equality between two objects is actually a complex task, which is why there are libraries for it. But for simple objects, it is possible to convert both objects to a special string representation known as JavaScript object notation. The acronym for it is written as JSON, and it's usually pronounced like JSON, although the inventor of JSON offers a different pronunciation that he considers to be correct.
I think the correct pronunciation is probably JSON.
The main purpose of JSON is to enable storage and transmission of objects, but it can also be used for equality comparison of objects. Using JSON.stringify converts the objects to JSON strings. We can convert both objects to JSON using this technique, and we can then do a regular equality comparison on the JSON strings to determine if the objects are equal. Note that this approach does not work in every situation, but it will work in most. An example of where it would fail is if a value in the object refers to the object itself. This is known as a circular reference and it is legal, but it cannot be converted to JSON. A full comparison between objects is not often needed. In most cases, it is only necessary to compare part of an object. For example, an application that guarantees unique ID numbers can simply compare the ID numbers instead of the whole object to determine if they are the same. This is both simpler and faster than comparing the values of every property. If you want to copy an object, the easiest way is by using the spread operator, which consists of 3 dots. The triple dot must be immediately followed by the name of the variable that you want to spread. Spreading has to be done inside of a container that can hold its result. This is the reason that the spread is surrounded by braces. Those braces are for delineating the beginning and ending of an object. What happens is the contents of obj1 are spread into a new object which gets assigned to obj2. Note that using the spread operator to copy an object only performs a shallow copy. What this means is it does a true copy at the top level. If you have a nested object, only references to the nested objects are copied instead of making full replicas. In this code, a spread operator is used to copy the first object into the second object. The inner object of second is a reference to the exact same inner object of first. The result is that changing a value of second's inner mynumber also changes first's inner mynumber. To create a deep copy, use structured clone. In this version, modifying the inner object of the cloned object has no effect on the inner object of the first object. If you're copying a simple object, the spread operator is generally the preferred option because it is a bit more concise and also has more browser support. There is another way to copy an object which predates the incorporation of the spread operator into JavaScript. Objects can also be copied using Object.assign. This code assigns the properties of employee to an empty object and returns that value, which is then assigned to employee 2. There are some subtle differences between how the spread operator and Object.assign work, which we will not discuss now, but Object.assign is more efficient when used to merge together existing objects, and that is now its primary use. This code modifies the person object by adding the properties of contact info. This does not change the contact info object in any way. Also, Object.assign returns the resulting combined object, but this code discards the returned value, which is why the syntax is slightly different from the previous example. There's much more to the topic of objects in JavaScript. We will continue with this topic in the next video.